A gas that follows Boyle's law, Charles' law, Avogadro's law, and Gay-Lussac's law is called an ideal gas. Now, we will combine all these gas equations. According to Boyle's law, PV is a constant. According to Charles' law, V by T is a constant. According to Gay-Lussac's law, P by T is a constant, and according to Avogadro's law, V by N is a constant. So we are going to combine all those four equations where we will finally get PV is equal to NT multiplied by constant, or PV is equal to nRT, and this equation is called an ideal gas equation. Thus, the ideal gas equation is PV is equal to nRT, where R is called universal gas constant. The value of R over here depends upon the units in which P, V and T are measured. Thus, R can have different values, or value of R for 1 mole of an ideal gas is 8.314 Pa meter cube Kelvin inverse mole inverse, or 8.314 into 10 raised to minus 2 bar liter Kelvin inverse mole inverse, or 8.314 joule Kelvin inverse mole inverse. Thus, if temperature, volume and pressure of a fixed amount of gas vary from T1, V1 and P1 to T2, V2 and P2, then P1, V1 by T1 will be equal to P2, V2 by T2. This equation is called combined gas law. STP condition refers to standard temperature and pressure, where standard temperature is 273.15 Kelvin or 0 degrees Celsius. Standard pressure is 1 bar or 10 raised to 5 Pascal, and at such conditions an ideal gas has standard molar volume 22.71098 liter mole inverse. Now, let us find out the relationship between an ideal gas equation and density of a gas. As you can see, PV is equal to nRT, or P is equal to N by V RT. This N over here is number of moles, and number of moles, as you know, is given mass by molar mass, or N is equal to small m divided by capital M. Let us substitute this value in the ideal gas equation, where P will be equal to small m RT divided by capital M into V. Now, small m by V is D, where D is the density, and density, as you all know, is mass by volume. So finally, P will be equal to D RT by M, or density D is equal to PM divided by RT. Next topic, Dalton's law of partial pressure. This law states that total pressure exerted by a mixture of non-reactive gases is equal to sum of the partial pressure of the individual gas. In a mixture of gases, the pressure exerted by the individual gas is called the partial pressure. Thus, P total will be equal to P1 plus P2 plus P3 plus at constant temperature and volume, where P total is the total pressure exerted by the mixture of gases, and P1, P2, P3 etc. are partial pressure of the individual gases. Gases are generally collected over water and therefore are moist. Pressure of dry gas can be calculated by subtracting vapor pressure of water from the total pressure of the moist gas which contains water vapor. Pressure exerted by saturated water vapor is called aqueous tension. It has a given value at a given temperature. Thus, P of the dry gas will be equal to P of the moist gas minus aqueous tension. Now, let us derive an equation for Dalton's law of partial pressure. We all know that from the ideal gas equation, P is equal to nRT by V. So, at temperature T, we have three gases enclosed in a volume V exerting partial pressure P1, P2, P3 respectively. Thus, P1 will be equal to N1 RT by V. P2 will be equal to N2 RT by V. Similarly, P3 will be equal to N3 RT by V. From Dalton's law of partial pressure, we all know that P total will be equal to P1 plus P2 plus P3. So, substitute the value of P1, P2 and P3 in that equation, finally getting P total will be equal to bracket N1 plus N2 plus N3 bracket close RT by V. The next step, we are dividing P1 by P total. So, P1 by P total will be equal to N1 divided by N1 plus N2 plus N3 multiplied by RT by V by RT by V. So, finally, P1 by P total will be equal to N1 divided by N1 plus N2 plus N3, where N1 divided by N1 plus N2 plus N3 is equal to Chi1, and Chi1 is the mole fraction of gas 1. You all have studied what is mole fraction from your knowledge of some basic concepts of chemistry. It is number of moles of one gas divided by total number of moles of all the gas present. Thus, Chi1 is equal to N1 divided by N1 plus N2 plus N3. This is because we divided P1 by P total. Had we divided P2 by P total, we would have got P2 is equal to Chi2 P total. Thus, for any ideal gas I, Pi is equal to Chi I multiplied by P total. This is the final equation for Dalton's law of partial pressure.